Know who is who. Yeah. Yeah, who is who. Okay, we are going to start. Good morning, everyone. Welcome to today's webinar. My name is Kabir, and I'm with Barliver Research Group. I will be your host today. Today, we have Dr. Jed Donald Groh with his colleague John Becker. They will be talking about understanding tissue testing, when, how, and what to do with the results. Before we dive in, I'd like to cover a few housekeeping items. If you have any questions during the presentation, please hold them until the very end. We will have 15 minutes for Q&A session. However, if something urgent comes up and you need my help during the webinar, feel free to type it in the chat session. I will be keeping an eye on it throughout the session. Without further ado, let's begin today's webinar. And now please join me in welcoming our special guest speakers. Over to you, Dr. Groh.
Thank you. We'll go ahead and share the presentation. So I am Jed Groh. I'm here in Northwood, North Dakota. I'm at AgVise Laboratories with John Becker. Today, like you said, we're going to be talking about tissue testing, using it as a report card, seeing what caused the plant to go wrong during the growing season, and whether or not it can be just an expensive hobby. As far as Northwood, North Dakota goes, this is kind of the outline like we talked about. AgVise Labs has been around for about 50 years. We are a full-scale agricultural testing lab. We do soil, plant, water, manure, feed, seed, soybean cyst nematode. We do samples all across the U.S., the Midwest. We also do a number of samples through Canada, especially Western Canada. We have a special permit we have with the USDA and the Canadian government where we'll bring samples down every day across the border. When it comes to tissue testing, it's very crucial that you get fast turnaround. And so we dry and grind them and post the results the next day. So within 24 hours, you can know what they give once we get them. So a lot of that involves perlator and overnight shipping, and we have special accounts and things with them. We post updates as far as summaries go for the region, residual nitrate levels in certain areas. I apologize for that. And we work with a lot of producers to set up seminars. Here you can see some of our team. There's me, John Becker is a soil scientist here. Brent Janish is down in our Benson lab. And we do all sorts of seminars across Canada. We do presentations and we release newsletters frequently. So the whys of tissue sampling. If you're here, you have some interest in tissue sampling. Typically, you see something in the field and it seems off, and you want to fix the problem. Some people try to monitor or check their fertility program. So they're going out there and they want to see what things are, happening, where things are. We can do that based off the mobility of nutrients. Some nutrients are mobile, some aren't once they get inside the plant. And so you can monitor this and kind of see where they are at different stages. Plants need, nutrients and different nutrients at different time. You don't often see, for example, boron deficiencies in potatoes, right? But you do see it in other crops. In Western Canada, sometimes you can see it in canola, depending on things. Now, tissue testing can tell you that, but there is a lot of things, testing the plant tissue that I can't tell you. Is it drought related? Is that why the boron isn't in the tissue? Different things. The reason plant tissue works is because you can dry and the sample out. You won't get any change as far as processes go. And then you can analyze the amount of nutrients on a dry weight basis. So based on that tissue, how much is being uptaken by the plant or has been uptaken at that point in time. And this kind of comes into a crucial part of tissue sampling. There are some things you can identify with tissue sampling. One is what the crop is doing right now. It's a snapshot. You can tell what has happened up to this point, how much have we uptaken. It will aid in decision making to this. If you do have a deficiency, well, do we need to put something on? Do we not? You can have, some sort of idea of, okay, well, this is what's going on with the crop. If it's not a nutrient disorder, is it a nutrient disorder? Is it a fungicide or a herbicide off drift as far as that goes, some sort of damage? Tissue testing can tell you that. We don't do that, but other labs can help you with that. And you can also see, other things. Then you get into the idea, well, if it's not any of these, then it can help. Well, maybe it's some sort of infection, etc. You can identify kind of how effective you're being with your fertility program, based off the placement or the source. Is it getting into the plant? Timing, did I get the timing right? Because you can see it uptake in the plant. Rate, is it adequate? I hesitate to say you can identify all of these, because then you get into some things that your tissue testing can't tell you. You can't predict the future. Often people will go out and tissue test, like, okay, are we going to make it? Looks like I have my slide settings off here, but we'll just keep going. Are you going to make it? Tissue testing can't tell you that. Can't tell you how much you have left. That needs to be accompanied with soil sampling, and we'll talk about that. And it can't tell you where the fertilizer is now. For example, you might go out there and see yellow in canola or yellow in wheat and assume, okay, well, it's sulfur deficiency after you get tissue testing. Does that mean the sulfur, the plant's going to get to it? Is it going to grow out of it? Is it not? Is it leached further down than the profile that we want? And again, it's another tool in the toolbox. A lot of people maybe talk about it like an answer to all your questions, but we like to think of it as just one more tool. There are some tests such as sulfur or boron that the soil sample, again, you can take a test, but then there's other things such as soil texture, how much precipitation you've received, that's going to play into that. And tissue testing can aid in those decision processes. So one of the main two reasons then is going to be fine tuning your fertilization program, right? So you might put some on and do we need to side dress later on? Or a diagnostic tool. Again, something's gone wrong and we want to check how it is. A good example of the first one would be potato petiole analysis. Potato petioles are sampled weekly, I believe mostly south of the region of the majority of the people here. You collect about 30 petioles from different areas of the field. You'll send them in. It's typically the fourth petiole. Different plants require different growth stages to be tested at different times. So different plant parts, at different growth stages. So the fourth petiole is crucial for potato sampling. You'll send them in with all the leaflets removed. You got to make sure you have a good sample, because otherwise, this is not representative. There's not enough there. Once you dry and grind them, there's not enough tissue to be tested. This is a really good example of why we do the fourth petiole. You can see here on the left, you'll have the second, third, fourth, fifth, sixth, and seventh petioles. It is advancing very fast, but you'll see the fourth petiole here. That nitrate level is the one most closely associated with your yield and your uptake in the nitrogen fertilizer you've applied. The younger potato petioles are still uptaking their nitrogen. They're still moving it there. They're still a sink, if you will. And so you might have a deficiency in that aspect, right? But not because there's not enough there or the plant can't get to it. It's still mobilizing that. As you can see in the older plants, there tends to be concentrated values there. It doesn't reflect the actual timing. Along with that too, if you get other nutrients that, you do have a deficiency, they'll begin to remobilize some of them if they are mobile. And so really, it's really crucial that whenever you take the plant petiole, or the potato petiole on this point, you take the fourth, but any tissue sample, that you have good timing. We'll discuss that later. Again, you can see here the differences. So when you do get your plant tissue result, you'll have a sufficiency range and you'll have a DRIS index. Sufficiency range tells you whether or not you have enough nutrients there for adequate growth. Again, this is dependent on the specific plant part and the growth stage of the plant. All of this is based off university research, where they'll go in and they'll add certain nutrients, they'll look at the soil test level, and they'll look at the resulting plant tissue level up until they have 100% yield. And then any amount of nutrient above that, and we'll talk about that as luxury uptake. You have the DRAS index is another tool there. And what this is it's a numerical index where they'll take the nutrient and its level in the plant relative to the others. So they'll say, okay, how much nitrogen do you have in the plant relative to potassium or phosphorus? For example, if you have a phosphorus deficiency, that's going to affect root growth. So you might have, sufficient levels of nitrogen, but based off the low phosphorus, maybe it's deficient. So again, it can help kind of parse some of that out where, okay, you're deficient, but is that the limiting one? Where should we address first? Indexes typically range from -20 to +20. They're normal. Anything outside of that, if you get below -20, that's where you can say, okay, we're deficient in all three of these, but this is the most deficient one. Because again, sometimes you can have AMS, for example, where we're applying nitrogen and sulfur and we can correct more than one deficiency. Other times we can't do that. And so we need to go after the one that is limiting your yield at that time. Again, this is just a good visual. You're deficient up until, hey, we have enough growth, and then you can actually be toxic where the plant's taking it up in luxury. This is the young plants to mature plants as they progress throughout the season. You'll actually see the sufficiency level decrease because they don't need as much. They're not as actively growing. They don't require the same amount of nutrients. This changes based off crop type too. So corn, for example, doesn't take up nitrogen as much in the beginning of the season. Potatoes, they're going to take it up the majority of it during tuber bulking. So they have different graphs that have come out from university researchers. This kind of helps with some of the back of the napkin math, if you will, where you can take a tissue test and then it can kind of give an idea based off the growth stage, what percentage of my overall nutrient have I taken up here? But it also means as you get further on, there are critical stages for applying these nutrients. Typically, for example, corn, you think of like V6 to V8, where, okay, we can make a rescue application here. Past that, some of your yield components are, they've already been established, and any nutrient that you add after that, the plant just doesn't need it as much. That window's passed and it won't do you any good. Again, diagnostically still, but as far as a rescue application, the utility isn't there anymore. This is an example of the DRAS index. I think if I advance and go back, that'll fix it. Where you can see the ratios here based off the uptake. So obviously you need more nitrogen than you need phosphorus and that sort of thing. So these can, as the plant ages, some of those change. The nitrogen to phosphorus one, not so much. Potassium to phosphorus, you can see it decreases a little bit. But for the most part, that stays consistent. So some of these things, despite the timing of the plant, you can use throughout the season. And AgVise Laboratories, we give both of these on your plant report, both the sufficiency level and the DRAS index, and we'll show you that later. You can see here, for example, this is, you have your nutrient level up top here. I don't know if you can see my mouse. You have my nutrient level up top here. You can see that both nitrogen and potassium are low, as well as zinc. But as far as applying things, what's the lowest hanging fruit? What do we go after? Well, you look down here and you can see based off these ratios that zinc is your most limiting nutrient. So right now, if you give it nitrogen or potassium, the crop still can't grow. It needs zinc. And so this can aid in again, that decision-making process. We're going to get into using your tissue data and reports. So what do you get? Okay, so you've tested your tissue, you've gotten your report back, it's shown you certain things. Well, what do we do with that? This is an example of one you'll get from AgVise. Again, you have here, this is the level in the crop. You have whether it's sufficient, low, high, or very high being that toxic or luxury uptake. In this case, you can see that although nitrogen is sufficient and everything else seems to be going okay, they did have, these were oats, and it just didn't seem to be doing as well as it should have. You can see here the DRAS index that although it has sufficient nitrogen, if it had more, we would be doing better, right? Compared to everything else, it's taken up plenty of phosphorus, The nitrogen just hasn't taken up as much. Now, again, then we look at, okay, you can cross-reference this with weather. Is it cold? Is it wet? That's why we use starter fertilizer, because phosphorus can help with that pop-up or seed place fertilizer at the beginning of the season. So you can look at different things here. Did I put any starter? Did I decrease my starter? Was there precipitation? Has that nutrients just leached out of the profile there? AgVise is, we pride ourselves on that next day turnaround as soon as it gets to us. So we'll bring it down from the Canadian border. We'll get it here. We'll dry and grind it, and we'll report it to you next time. Next day, we have a beautiful online AgVisor portal. You have all your plant, soil, tissue reports. And this allows the growers, this is an example of a potato petiole report. They can come in, and again, we talk about timing. Potato petioles, where you're pulling petioles entire season, this timing is crucial because you're fertigating, you're spoon feeding these plants. It's a little different than just going after wheat or soybeans, just kind of doing a one-off tissue sample. So, but this allows our producers to do timely fertigation based off real-time data. So when we talk about all of this stuff, really there's a method and there's a right way and a wrong way to do it. When you're troubleshooting your plants, say we go into a field and you have some sort of yellowing or twisted, stunted growth, really the ideal window is after you see the symptoms is to collect tissues 7 to 10 days. And later, the results can become a little skewed. Things can, deterioration of tissue, etc. That 7 to 10 day window is really crucial because once you start to feel symptoms as yourself, as you're sick when you go into the doctors, that's when they can help you. Again, the correct plant part is very important based off the growth stage of the crop. I gave the example of potato petioles. Seedling to boot stage or heading for wheat, you're going to want to just take the above ground portion of the plant. From there on out, typically it's the most recently mature leaf or the flag leaf. These are the ones that have been correlated to the sufficiency ranges put out by the universities or other private research organizations. We say don't forget a soil sample, and my colleague John Brecker will show you this here more. He gives a really good kind of frame of reference for people when he helps them, that the tissue sample is essentially your speedometer. If you're going somewhere and you look down and you say, hey, I'm going 60 kilometers an hour, that doesn't tell you whether or not you have enough to get to where you're going. That just tells you how fast you're going. Again, we talked about it. It's a snapshot. This is what's happening in the crop right now. It's not going to predict the future. It might help us kind of see what's happened up to that point, but it's just a snapshot. So that soil sample then is looking at your gas tank. And so that's important because, again, they go hand in hand, and he'll show you some paired examples here that we've done. So you'll take a tissue sample and you'll take a soil sample. Typically, if we're just kind of checking our fertility, making sure, hey, how are we doing? You can just take a tissue sample and a soil sample and see what's there. If we're diagnosing something, again, in this case, where we've got a symptom, 7 days later, we're taking a sample, hopefully, then you'll want to take a good sample and a bad sample. Again, we have some really good examples we'll go over. When you handle the sample, you're going to want to brush off any soil or dust. A lot of times you'll see on a tissue report elevated levels of iron or manganese, and these are just dust contamination from the soil. It doesn't actually reflect what the plant's been or has taken up. You'll ship samples immediately. Overnight shipping is the ideal situation. You'll pack them and you overnight ship them where they can be picked up. If you can't get them shipped right away, then you'll put them in a refrigerator, not a freezer. Freezer will damage the tissue, but you'll put them in a refrigerator, keep them cool, and you'll put them typically in a plastic bag, in a paper bag, not a plastic bag. A paper bag, something that will allow the moisture to escape, allow the plants to continue to breathe. So John Brecker here will get into some real world examples. These are some classic examples that we've actually done with our customers. So John, you'll have to advance and then go back, or just, I guess I've got the controls. So
actually, I can just steal the screen from you.
Let's do that.
There we go. You can see that just fine. Yes, Jed?
Yep, it's working.
Okay,
fine.
thank you. All right. Oh, you have timers on this. All right.
That's what I
So,
figured. Yeah. So you advance and go back. Yep.
okay. So, as Jed highlighted, plant tissue sampling, I always find its best case is for troubleshooting um, problems in the field. And we're going to go through a couple classic examples, looking at photographs, information from good and bad areas, and also the field information from the grower and agronomist. Because when you're trying to troubleshoot a problem, I'm wanting to try to build the picture for the types of evidence that you need to collect in order to really figure out what's going on. Because often we will just get one plant sample that's sent in from a bad area, and it seldom provides enough information to actually point to that smoking gun in that field. So let's look at one of the good old classic examples. This was an example in wheat where the producer had run into this case where they had these twisted little rat tail appearances after tillering on some spring wheat. And you can see the photos of the good area and the bad area. It's always good to have photos so you kind of know exactly what the problem is, especially when somebody calls you up and you're like, what's happening in this field? And so what we did is we ran the plant samples on these twisted wheat, and we got the soil analysis and next to the plant analysis. And in both cases, we have the good and bad plant samples run for a complete analysis. Because you never know what you're going to get surprised by when you have a good and bad plant sample. So in this example, the things that are different I've now highlighted. So what was principally different in the soil analysis was the copper was a little bit lower in the bad areas. Both areas had low chloride. Another thing that was different is the organic matter was lower as well as the CEC. So this kind of gives us the suggestion of a coarse textured soil, likely eroded because it's a little bit sandier, low organic matter. And then we look at the plant tissue as well, and we notice that the copper is low and the chloride are both low in that plant sample as well. Well, when we compare this against other photographs, reference samples that you can look at, to those classic little withered, twisted leaf tips, those matched the rat tail appearance of a copper deficiency. If it was a chloride deficiency, the leaf symptoms tend to be a little bit more non-distinct and often looks more like a worsened leaf disease. So in this case, between the plant samples as well as the soil samples, letting us know what's in the plant and in the soil, and also having the photographs in this case helped us confirm that it actually was a copper deficiency. So once you find out what the problem is, it's also important to have a corrective solution for that producer because, trust me, all of us are good enough at finding problems in the field, but the producer does want to have some solution. So going forward in a case like this would be a field where you definitely want to apply copper with small grains, either soil applied at planting or beforehand, or you could also think about planting a non-copper sensitive crop. Things like canola or pulse crops tend not to be as sensitive to copper deficiencies as small grains are. All right, here's another example. This was some thin stressed durum from Southwest North Dakota, and the producer had noted that these areas where the durum was struggling often had chlorosis and necrosis that would start in the lower canopy, and it would just have this drought stressed appearance. So they wanted to go out and see if there was anything different. Well, got the soil and plant samples collected, and I'm just going to highlight the things that were different. In the bad area, this soil profile, and this is just the top 6 inches, had a whopping 180 pounds of nitrogen just in that bad area. Yet, when we look at the plant tissue sample, the good versus bad comparison shows that it was deficient. So there you got a case where if you would have just taken the plant sample, you would have thought, hey, we got a nitrogen deficiency, but obviously the soil sample reveals that there is not nitrogen limiting. And then when we look at some of the other soil characteristics, the boron levels in this plant tissue were screaming at over 800 or 1800 parts per million. The sodium levels were also in the very high category. Chloride was also a little bit high. And then we look at the plant sample here, or I'm sorry, the soil sample, and we notice that the bad area had a lot of boron, 6.8 part per million. Normal boron levels are less than a part per million, maybe up to 2 to 3 part per million. And when you start getting boron levels that are above 3 part per million, this question about potential boron toxicity starts to enter our minds. Also notice the sodium levels were very high, and we look at the salts in that profile. The surface soil, not terribly bad. I mean, salts are only 0.44. Most crops should grow pretty well. But we then look at the subsoil salts, and that's up at 3.5. So there definitely is something going on with the boron and the sodium. And we start to compare what's going on between the plant tissue and the soil test levels. I think we got a good case of boron toxicity that's also probably linked up with some sodic soil characteristics. Um, Another thing that the producer noted is he only would run into this problem in this field when it was in small grains. But when he would plant sunflower, they never saw those type of drought-like symptoms. And sunflower tends to be one of these crops that has a higher boron tolerance. So that's why they weren't seeing it in the other crops. It was basically these more sensitive small grain crops where, in this case, we had a good story with the plant tissue and the soil test levels, as well as the growers' field notes about comparing that boron toxicity question with the sunflowers. That helps us actually help flesh out this story. So, as far as preventative measures going into the future, these areas of boron toxicity are usually related to local geology. So the best option is crop rotation and selecting crops that tend to have stronger boron tolerance. So sunflowers, canola does better. Alfalfa, that'd be another good crop that has a little bit higher boron tolerance. But you can also run into cases where those boron levels are so high that even our more tolerant crops don't survive very well either. So some of those might then be best planted to grass or something else. That's kind of the classic story if you have salinity issues. So we also did a couple other case studies in 2018 where we actually sent out troubleshooting materials, paired plant bags, paired soil bags to lots of customers that were just encountering problems. And we asked them to take photographs, take field notes, and then send in the soil and plant samples as well. And so I got a couple different examples that I'll share here with some purple corn coming from southern Minnesota. Had some stunted safflower coming out of southwest North Dakota, and then also some yellow wheat up on the northern tier of North Dakota. So the first example, got some purple corn here. You got these bad looking samples on the left. They're shorter, they're stunted, they have a V3 growth stage compared to the good looking areas that are up at V6. You got these purpling of the leaves, getting a little bit of a striped appearance as well. And also we're starting to lose some of those lower leaves with some necrosis popping up on those lower leaves. Looking at our data, comparing the good and the bad areas, I'm going to start off with the plant samples in this case. What pops out as deficient or low in the comparisons is the phosphorus and the zinc levels are a little bit lower. And actually, when we look at the soil levels, we notice that the soil phosphorus and the soil zinc levels are also a little bit lower. Now, they're not crazy lower. Like these bad phosphorus levels are still in the medium range, and the zinc levels are still kind of in that medium soil test zinc level as well. But one of the big differences in this field is the bad area also has some pretty high salts up in the twos. And at this point, you would expect to see some type of salinity stress in a corn crop as well. So to kind of compare the two aspects here, in this purple corn that is really manifesting itself like a phosphorus deficiency, is we do note that that plant tissue is deficient in phosphorus and low in zinc. The soil test also confirms that, but it also points to another problem like high salinity. So as far as corrective measures going forward, definitely would make sure that you have sufficient starter phosphorus and zinc to help correct those issues. But another thing that we got to stay cognizant of is that seed safety of putting a starter fertilizer in furrow coupled with that salinity problem. And also recognize that the salinity, which is probably our biggest stressor in this case, is going to limit that plant uptake. So where we see lower soil test levels to begin with, like phosphorus and zinc, it is impairing both of those from getting into the plant. And also recognize the salinity stress in your crop choice. So corn is one of those crops I would consider a little bit more moderately tolerant to salinity, or actually I'd probably say it's a little bit more moderately susceptible. It's not as susceptible as like a pulse crop like peas or soybeans or um, chickpeas, lentils to salinity. But it doesn't have the tolerance of canola and certainly not the nice tolerance to salinity like barley. So there you maybe think about some of those other crops in a situation like this. Here's another case study looking at some safflower. This was in southwest North Dakota where the grower had just noted these very poor stands in stunted sunflower or safflower plants. And the photo on the right gives you kind of an overall look at the field, but the photo on the left actually shows you the good and the bad plants in this field. The ones on the left are the good plants. The ones on the right, where they are these little tiny, about inch high plants that are just teeny tiny, those are the bad areas where they were noticing these problems. So the client went out and collected some good and bad samples. We're going to focus on the plant sample first. You notice that the phosphorus level in both of these plants is low. It falls into the low category. But when you look at the phosphorus levels, those are actually pretty high phosphorus levels. The critical level for Olsen phosphorus is 15 part per million, and both of these cases have very high phosphorus up into the 25 to 23 part per million range. So we have a phosphorus deficiency in the plants, even though we have very high phosphorus in the soil. One other thing that really stood out is the amount of manganese in these plants. In this case, the manganese in the bad area was 800 part per million. This is really, really high compared to how most levels are. The good area still had high manganese in this range. And well, we're going to jump to the pHs here. You notice these pHs in the good area is 5.6, but the bad area was way down at 4.5. So we are definitely in the screaming acidic area. And we often get aluminum toxicity problems that start to appear when soil pHs get below 5, 5.5. So what ends up happening is aluminum starts to become available in the soil, and that is very toxic to plant roots. And you get these short little stubby root systems, just like we saw in those photographs. Another associated toxicity that we can find in acidic soils is manganese toxicity, because the manganese levels in soil also go up. And plants aren't very good about managing manganese uptake. So if you ever run into these acidic soils, you can also run into cases where you'll get really high levels of manganese in the plant as well. So you not only have aluminum toxicity, but you also will have manganese toxicity that appear. Now, whether it's manganese or aluminum toxicity, I don't really care. At the end of the day, it's just a soil pH problem. So we have to think about how to manage that soil pH issue. Just to give you an idea for what happens with aluminum toxicity, here's some wheat seedlings that have been exposed to high amounts of soluble aluminum that is present as Al3 plus versus known aluminum. And you can just see how those root systems are different when they're exposed to high amounts of aluminum. And to give you some yield data, again, we don't really worry about the problems of aluminum toxicity until those pHs get to be about less than 5.2. But you'll notice in this graph, as those pHs get less than 5.2, getting closer to 5, the amount of exchangeable aluminum in the soil increases. It's not a very big increase. It's a pretty slow and gradual increase. But you notice that the amount of aluminum also goes up in the plant. But what really tanks is that grain yield. And you notice after you get below 5.2, down less than 5, that grain yield and plant biomass just drops like a rock. So it doesn't take a lot of aluminum to cause a big problem. So I asked the grower to go, or the agronomist to go back out to this field and actually subsample the soil profile into 2-inch increments with a 0 to 2 at the surface, and then do a 2 to 6 and then a 6 to 12 just to see how stratified the soil pH is. And in the good area, the upper 2 inches was a very little, it was a tiny 4.5 pH. But by the time you got to the 2 to 6 inch, that pH was up around 6. So you wouldn't expect to have aluminum or much aluminum in that 2 to 6 area. But in the bad area, it was in the 4s all the way through the 6-inch profile and still less than 6 down in that 6 to 12. We then measured the aluminum as well, and wherever those pHs were less than 5, you see there was quite a lot of aluminum, 24 part per million in the good area, 91 part per million in the bad area, which is absolute screaming amount of aluminum. But then you get into the 2 to 6, and wherever that pH was near 6 and above, you notice how there's very little aluminum. And if you have pHs that are above 6, you shouldn't have like any aluminum in that soil profile. So that's good to see. Those manganese levels also were very high where that pH was low. But really, the big problem here is that aluminum toxicity. So wrapping up this case study with the stunted safflower, if you were just to go out there with plant tissue samples alone, it would have pointed to low phosphorus in both. So, if you were just to run off that data, you would have say, yep, go ahead, spread some phosphorus out there. But you also notice that there was some high manganese, and when you see high manganese, that either points to one of two things. One, soil contamination due to dust on those samples, or in a case like this where you have the good and bad sample where you see really, really high manganese on the bad area, there could be some potential manganese toxicity. But what was most helpful in this case was the soil test that confirmed there was very low pH and very high aluminum. So as far as corrective actions in this case, crop choice is probably your most important decision, especially in areas that do not have good access to lime, which would be like areas in most of North Dakota, most of Montana, as well as most of Saskatchewan and Alberta. There is lime available in some places, but overall, I wouldn't say that we have a lot of mineable limestone in most cases. So crop choice, things that are more tolerant. Safflower, we found out that it is a very, very sensitive crop to low pHs. Another possible option is placing a high rate of seed placed pea. This has been a strategy used in the southern Great Plains where they also have a lack of lime. In Montana, they've been doing some work with this as well on these troublesome acidic soils. And they'll apply like 40 pounds per acre of P2O5 in furrow. And you could do this with a more tolerant crop to high rates of seed place phosphorus, like small grains. You're not going to do that with canola because you're going to causing a salt stress in furrow as well. But what ends up happening is the phosphorus starts to bind up with the free aluminum and helps keep it out of that root zone while that seedling is getting going. And this works well if you have higher pHs in the subsoil where they can actually get to some more hospitable soil conditions. But if the subsoil pHs are also acidic, the high rate of seed place phosphorus doesn't seem to work as well. And ultimately, probably the best option is lime application. If we can actually apply lime and increase that soil pH, that is going to fix all of these problems. And that's why I don't get too caught up in is it iron or is it aluminum toxicity or is it manganese toxicity? At the end of the day, it's all about pH management and just making sure you have a soil pH above at least 5.5 to correct that issue, but ideally 6 and above if you can. All right, last case study I'll go through is some yellow durum. This was up along the northern tier of North Dakota, just south of Manitoba. And the producer noticed that they had the yellowing of some upper leaves. It was worse on the hilltops. They had a very thin stand up on the hilltops. And this type of symptomology really does look like sulfur deficiency in a lot of cases. And so when we ran the plant samples and the soil samples in both cases for the good and the bad areas, the data came back the exact same. There was no real big difference in the nutrient deficiency symptoms. So after pointing out a few different cases of good and bad plant samples with soil samples, where we usually can tailor if it is a soil related issue or a nutrient related issue. I point out this case because sometimes the plant and soil samples don't really tell us much. Based on the visual symptoms alone, sulfur deficiency was probably the most likely issue. Well, the grower, after they had gotten back this data, still wanted to do something. So they did go out there and spread some AMS over the top, and it didn't do anything to fix the symptoms there. So this is my final case looking at an inconclusive situation where we have to think about other problems beyond just soil and nutrient issues. For example, it could have been a herbicide carryover issue. This particular year, it was a dry spring. There was also maybe some surface pH issues, some high pHs on an eroded hilltop that could have caused a difference in herbicide carryover breakdown that was maybe causing an issue, as well as just thinking about water availability on an eroded hilltop, or also cases of positional nutrient availability. Maybe you have applied your nutrients at the surface or in a surface band, but maybe it's extremely dry at the surface and the plant roots can't take up any water or nutrients from the surface, and they're obtaining most of their nutrition from subsoil layers where that crop nutrition is at. So then we have to think about other things. So if I were to summarize these cases, a single plant tissue analysis report is usually not enough information to really build a conclusive case when we're troubleshooting problems. We also have to recognize that those plant nutrient concentrations are going to be affected by plant size and growth stage. There's going to be differences in fertilizer rate, placement, timing, and source, as well as soil moisture and compaction that can affect those nutrient concentrations. So that highlights why the good and the bad plant and soil samples are really important to make sure that we can compare similar growth stages at that same time. So I would like to have the good and the bad. And it also tells us if that soil nutrient supply is truly lacking, or if it's just an uptake issue, or if there's something else going on, particularly like those soil pH cases and those soil salinity cases. A plant tissue sample is never going to tell you if it's a salinity or pH issue, and that's why those soil samples are also very, very important. All right, so that wraps up my portion on the troubleshooting side, and I'll turn this back over to Jed to kind of wrap her out. Jed, you're still on mute.
Okay, should we open the floor for Q&A now, or?
I've got just a few more slides here, really
Okay.
quickly, if you don't mind.
Yeah.
Um,
Yeah, go
so-
ahead. We have a lot of time.
Yeah. So basically, as far as what John has said, and he does an amazing job. That's why I was really happy when he said he'd jump on here, just showing that tissue sampling is one tool in that toolbox. So if you do go out there into the field and you see something and you take a tissue sample, oftentimes they'll call us and ask what the problem is. It's difficult to say based off one sample alone. Also, if you're looking at, tracking nutrients throughout the season, or you're like, okay, well, how are we doing? One sample, time-wise throughout the season isn't even enough. There's a lot that can be done with tissue testing as long as it's done right. But just taking a snapshot and drawing conclusions is often difficult or ill-advised. There is a lot of things out there, micros, new fertilizers, foliar applied applications, biologicals, where people are testing more or claiming things. And a lot of this stuff, it talks about overall uptake biomass, or foliar, this can do this, or this can do this. And tissue sampling can help, kind of weed out the snake oils. One of the misconceptions, though, is that these will, they can't be picked up in tissue sampling or et cetera. I've heard some arguments that way. And really, when you dry a tissue sample down and you run it on our machines, you can test these nutrient levels. It can be measured. Another couple of misconceptions is, well, tech will make this an antiquated thing. AI and algorithms, we won't need to go out there into the field and tissue test individually. And the reason this is important is kind of looking for the future. We've had NIR or spectral things. We've had drones in the past. And basically what we found is, as far as measuring the nutrients in the plant tissue that we need, it is this wet chemistry that gives you the most accurate results. It tells you what is there. There are a lot of people that do kind of cloud-based data algorithms, these AIs, where they'll go out and they'll say, okay, based off, all these other field examples, and your nutrient levels, this is what, they'll measure one thing that they can measure and draw conclusions based off the other. AI has its place, certainly, but when it comes to several of the cases my colleague showed you, if you were to run that through an AI, it would have said, well, based off the symptomology and pull it out, it's this, without actually going in there and seeing what it is. It's ineffective. SAP testing too has been, has been and still is a big source of information in several plants. Some people argue that it's better, or they try to sound different or new. really at the end of the day, Carl Rosen out of the University of Minnesota, and a couple other people in Montana have done tests where they've correlated it to the dry matter, and it's the same nutrients. It's a different way of measuring, and as long as you have a calibrated method to go along with it, it's nice because you're out there in the field, but there's some variability to it as far as sampling and stuff goes, and so there's a lot of these keywords or hot topics that people throw out. But at the end of the day, the reason we still soil sample and the reason we still tissue test via wet chemistry is because it works. So, it's just kind of a plug here at the end. Here at AgWise Laboratories, we do a lot of tissue testing and soil sampling throughout the season. We have John Brecker, that beautiful demonstration, he's amazing. I'm here as well. I won't toot my own horn, but we do have a wide variety of knowledge when it comes to crops. And across the Canadian prairies, we're not just in a corn soybean rotation here in North Dakota, but just like Western Canada, we grow a variety of crops, from lentils to dry beans to alfalfa to potatoes and sugar beets. And we have this expertise, and we love to help with questions or concerns. So if you do have a field or you have a client, go ahead and give us a call. That's what we're here for. Take a tissue sample, take a soil test, and we'd love to help you answer any of your questions. Speaking of answering questions, that should leave us with the 15 minutes to answer any if you have any. You can ask me or John Brecker.
Perfect. Now we will open the floor for Q&A session. And if anybody does not like putting their question in the chat session, they can click on the raise hand button and I can allow them to talk. Are there any questions?
Well, we've either done a really good job at
Yeah, I
conveying
guess
all
you
the
guys.
information, or you've fallen
Yeah.
asleep. So one of the two.
Yeah, I guess
All
maybe you
right.
guys gave an amazing presentation that
We'll go with that.
people understood everything. Okay, let's wait for another minute or two. Sometimes it takes longer for some people to type in. And then when I'm sometimes doing the closing and then there's a question.
If you just want to ask
If you
again,
guys want
if
to add
it's
on,
easier.
yeah. Is there anything else you guys want to add on? Like unless somebody's typing the question. Like anything for last minute thing, anything for closing? Oh yeah, there you go. Just wondering
Ah,
any soil health indicators in tissue testing.
okay. Soil
Good
health
question.
indicators. Okay. We do various soil health indicators, but I will tell you it's mostly done in the research world. There is a big lack of any interpretation for the various soil health indicators that are out there. I'll just give you a rundown for a lot of the stuff we do. So we do CO2 respiration, the Solvita burst. We can do the Haney test that includes the water extractable organic carbon and nitrogen, as well as the H3A extractable nutrients. The Haney test in particular has actually fallen out of favor within the NRCS and the research circles, just because it's tend to have been a very noisy test. It tends to be too much influenced by weather patterns. So if you get a wet period or a dry period, those numbers actually bounce around a lot. So after 2019, actually, the NRCS replaced the Haney test with a couple other ones. Active carbon or POC, ACE protein, which is a measurement of bioavailable nitrogen, as well as total organic carbon. And my favorite is actually aggregate stability. So now we're actually looking at physical parameters. So a lot of these soil health indicators have actually been proposed more as tracking tools for soil management. And here I want to be very clear about soil management versus crop management. When we talk about soil management, here we're talking about changes in tillage systems, or we like switch from conventional till to no-till, or maybe we've been no-till for a long time. Now we want to do some strip till, and we want to make sure that our soil quality isn't going backwards. Or maybe you're bringing in cover crops or some other soil health practices to help mitigate erosion, etc. And so in those cases where you actually are changing the system, some of these new soil health indicators, or actually I like the term soil quality parameters better, you can actually measure things, but these are long-term changes, 3 to 5 years. Now, where I want to differentiate this between soil management and crop management is usually producers are looking for crop management questions like, can I actually reduce my fertilizer rates? Can I change my plant populations? And so far, the university research has not shown that these indicators are really that good at answering any of those questions. We're still very much in the wait and see phase of what the university research is going to point out in these cases, but based on the initial stuff, I don't think we're going to see a lot of huge changes there. It's just remembering that we're kind of chasing after different types of parameters than these agronomic. So that's where I like to be very clear about soil management versus crop management. Now, coming back to one of my favorites, aggregate stability, because what I really like about aggregate stability is we're now actually measuring like physical parameters, and we're physically, aggregating all these good practices together, like reduced tillage, or diversified crop rotations, things like that. So it can tell us quite a bit about like erosion and water infiltration, but it's probably not going to tell us a lot about crop management or change in fertilizer recommendations since you have better aggregate stability. So that's where we just have to put on a very different hat than what most producers are used to wearing when we think about soil quality. I think that's why I still like the phrase soil quality, because it kind of lets us think about something's fitness for use and your use of that soil as a producer. Well, if you're growing crops versus as a rancher, how you use that soil is going to be a little bit different, and what good quality soil means in those cases is going to be a little bit different, and it probably does bring in quite a bit of subjectivity. Okay, I could rant about that for a while, so I better wrap up there. Follow-up questions, please.
Awesome. Hopefully that answers your question. Are there any more questions? Yeah, I guess let's wait for another minute, and if there's no more question, then we can wrap up.
Yeah, as far as while people are thinking of their questions, I'll just say as far as working with AgVise, if you want to reach out to one of us, we can tell you a little bit more about what we offer. But again, we have several pickup locations in Western Canada, mostly throughout Manitoba. And so we have special contracts with Perlator and other things. So you would contact us and we'd give you that information. You can ship plant tissue overnight to one of our locations. We pick it up and bring it down, dry and grind it, and give you the results.
It would just be regular ground shipping.
Oh, ground shipping. Thank you.
Yeah.
And we'll get
so
the tissue. Yeah, go ahead.
Yeah, so everything gets shipped to our receiving address in Winkler, Manitoba, and then we run a route service 3 days a week during the spring and summer. We grab things and pull them across the border. It's much faster than shipping directly across the border because stuff can get caught up in customs, where if we just go up there and physically bring it across, it happens much faster. So for most locations in Western Canada, that might be 2 days shipping, kind of probably from your neck of the woods to get to Winnipeg. So you'd have results usually within 2 to 3 days. So yeah, it actually works out really well. And we've been doing like that for about 30 years, longer than I've been here. So it must be a system that works.
Perfect. Is there anything else you want to add on, like Dr. Groh?
No, John's covered most of it. So
Okay.
I think
Thank you guys for your time.
Yeah.
Okay, I guess then we will just conclude the webinar. Thank you, Dr. Groh and John, for answering those questions and for an excellent presentation. It was truly a pleasure to have you guys with us today. That brings an end to our webinar. Thank you all for attending, and we hope you found this webinar informative and useful and you enjoyed the discussion. If you have any feedback or suggestions for the future topics, feel free to share with me via email. And if you want to contact AgVise, or if you need Dr. Groh's email, like you can always send me an email and I can forward it to you. Yeah. Thank you. That concludes the webinar. Thank you guys for coming up today.
Yep. Thanks for
Yeah.
having us.
Thank you.